Hello everyone. So today we're going to present about energy storages for solar farm, and our group member consists of Thanakrit, Pakhin, Chalisa, and Napassarawadee. So solar energy is a renewable energy and it is only available during the daytime. So to maximize the exploitation of available solar energy, an effective energy storage is needed, which can be collecting the available excess solar energy during the daytime and give back when needed. So we picked three energy storage for solar farm. The first one is hydro pump storage. The second one is supercapacitor, and the third one is molten salt thermal storage.
So the first one that we're gonna be talking about is the pump storage hydropower. Before we know how the pump storage hydropower works, we need to know its component. The first component is the solar photovoltaic array or PV array, which will be connected to the second component, the MPPT or maximum power point tracker or the inverters. It will connect to the PV array to extract the maximum amount of power from those photovoltaic panels to send to the grid. The third component is the controller, which will be using to transfer the energy directly to the electrical grid and to the pump hydro storage section. The controller will be connected to the pump motor to pump water from lower to the upper reservoir. The turbine generator will be used to driven by the water to release from the upper reservoir. Lastly, the upper and lower reservoir is used to collect water. So how does the pump storage hydropower works? The pump storage hydropower or PSH is a type of hydroelectric energy storage. It's configured with two water reservoirs at different elevation that can generate power as water moves down from one to the other, passing through a turbine. The pump hydroelectric storage store energy in the form of water in an upper reservoir pumped from another reservoir at a lower elevation. During the period of high electricity demand, the power is generated by releasing the stored energy stored water through the turbine in the same manner as conventional hydropower station. During a period of low demand, usually at night or weekend, when electricity is at lower cost, the upper reservoir is discharged by using lower cost electricity from the solar farm grid to pump the water back to the upper reservoir. PSH acts similarly to a giant battery because it can store power and then release it when needed.
And there's a main advantage that suggests the PSH that's suitable for energy storage for the solar farm. It can provide energy balancing, stability, storage capacity, and ancillary grid service such as networks, frequency control, and reserved. And it also have other benefits such as it can be flexible to start-stop time and has ability to track the changes between demand in electricity and water supply. It can adapt to sudden change of load and quickly respond to high density energy. And it also can maintain the voltage stability and frequency modulation. It is considered as green battery that has high efficiency up to 85%. And lastly, it has exceptional lifetime of 50 to 100 years.
So the materials used for a supercapacitor, the electrolytes have thin coatings connected to a current collector, and they have a wide variety of materials used, such as activated carbon or graphite. So for one study, they used manganese dioxide, and there is no dielectric. So the plates are soaked in electrolyte and are separated by a very thin insulator such as carbon, paper, or plastic. And for the electrolytes, they can be either aqueous or organic or ionic. And for the separators, they have to be ion permeable to allow ion flow between them. So this is a diagram showing how a supercapacitor uses a solar energy grid storage. So the sunlight hits the PV panel and the energy is converted to the control unit using a supercapacitor. Along with a grid energy system, the energy is distributed to households. So there are no chemical reactions and the energy is stored on the surface. So electrical energy is released back into electricity during discharge, which gives us power. Supercapacitors have high energy capacity and fast charging and discharging ability, which makes them ideal for solar farm grid energy storage. So as you can see from the graph, they have high energy density and power density when compared to other common devices. They can perform well in both high and low temperatures, and they can cycle a million times over, and they have reduced size and weight and are environmentally friendly as well.
The first one is molten salt thermal storage. It is composed of heliostat mirrors. It's used to control by computer to follow the movements of the sun and reflect the sunlight to the receivers. Then the receiver, as the thin wall stainless steel tube, used to receive the sunlight. The third one is hot molten salt tanks. The size of this tank depends on the requirements of the utility and store energy to use after the sunset. The fourth one is cold salt thermal storage tanks. It is used to store the used molten salt for later utilization. Heat exchangers or steam generator is used to transfer the energy from the working fluid to storage and to transfer the energy in storage back to the steam system. And lastly, the steam turbine is used to generate electricity.
During the daytime, heliostats will follow the movement of the sun to reflect the concentrated solar radiation to the receiver. Then the molten salt central receiver on the top of the tower is heated. The cold molten salt stored in the tank at the base of the tower are pumped up to the receiver where they are heated at very high temperature. Then they go down to the store tank where they can be stored to maintain electricity production for several hours as it is still heat. And when the electrical energy is needed, the hot molten salt is sent to the vapor generator in a few minutes to activate the turbine and generate electricity.
The reason that we show this technology is because it is zero-emission technologies, as molten salt is non-toxic materials and stable chemical, so it is environmental friendly. Also, it is cost-saving because the molten salt heat transferred to the receiver is isolated from the main steam temperatures and process and pressures, with resulting in operations at low pressures. Also, it is unable to work 24 hours a day. Most importantly, it is high cycle efficiencies due to molten salts can be heated to 1050 Fahrenheit, which allow high energy steams to be generated at 1075 Fahrenheit. Lastly, the system is designed to minimize the length of the molten salt loop to less than 2,500 feet, with a heat tank to prevent freezing. Thank you.